Okay, so student, we are going to understand the new chapter, which is the sound. It is a part of your physics, beta. It is the part of physics. So first we have to define what is sound, and then we will discuss about the chapter. So I'm just going to write the definition for sound. Definition. Okay. So what is sound? Sound is the kind of energy. The kind of energy. Somebody is in waiting room. Wait a second. Okay, the kind of energy which produces the sensation of hearing. The kind of energy and which is produced due to vibration of particles and which produces the sensation of hearing is called as sound. Is called as sound. Okay, it's called as beta sound. Now, like in our surrounding, we have different instrument they use to produce sound. Is it? Yeah. So just we will discuss about the types of sound now. Types. And one more thing, how sound travels. So I'm writing a very important point here. Sound produces due to vibration of.
Sound is produced due to vibration of objects.
Of an object. It produces due to vibration of an object. Second point, sound propagates. Sound propagates. Instead of propagate, we can write travel also. Travel through medium. Okay, medium is what? It is the part where particles are present. Okay, that means sound cannot travel in vacuum. So I'm writing here sound does not travels in vacuum. Sound does not travel in vacuum. Sound always travels in a medium. It may be solid, liquid, or gas. It may be solid, it may be gas, it may be liquid. Okay, it does not travels in vacuum. Sound produced due to vibration of an object. Last but not the least important point, sound propagates
faster through solids.
Sound propagates due to compression and rarefaction of.
So also, is there no sound in space?
No. Sound propagates due to compression and rarefaction of particles. Okay. Last but not least.
Sir, sound like the waves travel in different speeds.
Yes, wait a second, let me complete that. Sound propagates faster in denser medium like solid.
Sir, solids.
Yeah, solids. Okay, then liquid.
Then gases.
Yeah. So these are the important points that we had to remember regarding sound. Okay, so take a screenshot. Now we will move further. Okay, so now we will discuss about, here we have like mentioned due to vibration. So we have to discuss what is vibration is all about. So I'm writing here next study vibration.
So it's up and up, it's to
See,
and fro, or up and
so let me discuss. Vibration can be defined as the rapid vibration is the rapid back and forth movement of a body or particles about the center or mean position or mean position is called as vibration. Suppose we have one particle over here. Okay, so if that particle moves in back and forth, means, you know, when particle will move from here to here, okay, then from here to here, and again from here to here. Okay, so like this. Okay, so this movement is a kind of oscillating movement. This movement is
so
called
like in
as
sound
oscillate,
waves, it transmits the
like pendulum. Okay, suppose pendulum is over here, and here we have the string, and this is the bob. Okay, if we will release that pendulum from here, so it will go like this from here, then from here again it will come back to the this position, again from here it will move in this direction like this, so it will continue. Okay, this movement is called as beta oscillation. So particles of the solid or maybe liquid or gases, when like they are producing the sound, and when they are going to travel the sound through them, okay, they oscillate with their mean position back and forth like this. Okay, in order to receive and to transfer vibration to the next particle, they are oscillating. Okay, that movement of the particle back and forth is nothing but vibration, and this movement is called as beta oscillation or oscillating movement. Okay, now I want you have to take a screenshot for that. Now we have to discuss how sound travels. So here we have that speaker which is connected with the device, electronic device, which produces the sound. Okay, so when like some like we are playing some cassette or CD or some song, MP3, MP4. Okay, so this is the speaker, which is the electronic device which converts electrical energy into sound energy that produces the sound. Okay, and see here, this is the membrane which used to vibrate on its mean position, again back forth over here, and ultimately it produces the sound. So due to vibration of that membrane of the speaker, surroundings particle of air, when they are contact with that membrane, they also get vibrate, and one particle which used to transfer its vibration to the neighboring particle by oscillation movement like this. Okay, then that particle, when this particle of air, when they comes close to each other in order to transfer the vibration, okay, that reason here the particles are very dense, as you can see here. Okay, so that reason is called as beta compression.
Yes,
That
sir, you
reason is
told this yesterday.
yes. So this reason is called as compression. And when they are moving, okay, apart from each other in order to like transfer vibration to the neighboring particle, okay, they are moving apart from each other. So that rarer region, as you can see over here. Okay,
Sir,
where
can you
particles.
write the two names in the board?
Rare friction. Yes, compression and rarefaction I will write. Wait a second. Okay, so this is the compression region and this is the rarefaction region. Okay, so let me write the what is compression and what is rarefaction. So I'm writing here compression. Compression. So when particles of medium, the medium may be solid, liquid or gas. When particles of medium comes close to each other, come close to each other to receive the vibration is called as, okay, medium. When particles of the medium comes close to each other in order to receive the vibration is called as compression. Okay, so this is the reason for compression. Now I'm writing the rarefaction. Okay, rarefaction. When particles of medium move apart from each other to transfer vibration to neighboring particle is called as rarefaction. Okay, so this is the reason for rarefaction. Okay, so continuous compression and rarefaction of the particles of the medium, sound travels from the source. So this is the source. Source is source for the sound. Okay, and here the point of hearing. Okay, listener. So between the sound source and the point of hearing, that sound waves, they produces the wave-like structure. As you can see, I have drawn here the waves also. Okay, like this. So that particular region, the topmost region is called as beta. I'm changing the color for that. It's called as crest. Okay, and that the depth region, that one, okay, is called as trough. Okay, so it is the crest and it is the trough. So I'm writing here, it is the C, it is T, it is C, it is T. So crest, trough, okay. So like this, waves are being transmitting from one place to other. Okay, so this is the how sound travels from source to the listener. Okay, everyone. Okay, one more thing, like
Yes,
here
sir.
we have small like many concepts are here, so I'm just writing first concept. Okay, so the distance from one crest to other. Okay, so distance from one crest to other is called as beta wavelength. Okay, it is called as wavelength. Okay, so I'm writing here what is wavelength.
क्या चाहिए?
Okay, it is wavelength. Okay, so what is wavelength? The distance from,
So like the distance between two alternate compressions or
yes,
radiations.
yes. So instead of compression and reflection, we can write crest and trough also.
Yes,
Okay,
sir.
yeah. So the distance between two crest or two trough, or instead of crest and trough, we can write compression and reflection also. Is called as, but here we are using the word wave. That's why we had to write crest and trough. Okay, because we had to show it in the form of wave. So it's called as wavelength. And it is denoted by lambda. Okay, this is a symbol called lambda, LAMBDA. Okay, lambda. Okay, so take a screenshot. Now we are going to discuss the next concept. Done?
Yes, sir. Taken.
Okay. Next. After wavelength, we will discuss the amplitude.
Okay, sir.
Amplitude. See, if I'm going to draw a straight line from the center of the waves, okay, so the distance from here to the crest or from here to the trough, okay, suppose we have a pendulum here, okay, suppose I'm just having pendulum here and it is moving in like this, in this direction again, and from returning back to the mean position and again moving to that position. Okay, so pendulum is moving like this continuously. Is it? Is it? Do
Yes,
reply.
yes,
Yeah.
sir. Yes,
So
sir.
yeah. So the maximum displacement of pendulum from here to here, or that bob, okay, is called as amplitude.
Max, so the maximum displacement.
Yes. So here also, okay. So here the maximum displacement of the particles in order to receive or transfer the vibration is called as its amplitude. Okay. So we are not discussing here pendulum. We are discussing about the particles. Okay. Sound waves. So I am just going to write related to the sound wave only. So the maximum displacement of displacement of particles of medium okay, from its mean position, from their mean position is called as amplitude. Okay, so I'm writing here, I'm using other color for that, yellow color. Okay, so this is wavelength. Let me change the color, red. Okay, this is the wavelength. Okay, and from here to here, that distance, okay, or from here to here, this is the mean position, okay, and this is the maximum displacement from here to here. Is it? So this is amplitude. Okay, everyone getting the point?
Yes, sir.
Okay, now next concept is the time period. Very important point we are discussing, time period.
Yes, sir.
Okay, you know that amplitude is represented by new sign, new, like this. Okay, wavelength is represented by this
Yes,
sign,
sir.
small lambda. This is a small lambda. Okay, next,
Sir,
time
what
period.
is a lambda?
Lambda is wavelength. Like pi, we have theta, we have these are the Greek word. So likewise, we have lambda, nu. Okay, they are also the Greek letters we are using to represent the wavelength, amplitude. Then we will use frequency also. Okay. Yeah.
Yes, sir.
Okay. So frequency is represented by that nu. Okay. Now next time period we are going to discuss. Okay. So see here the time taken. Suppose Bob was here. Uh-oh. Bob was here and it is taking time from moving here and from here to here. Okay. Or from here to here and from here to here. Okay. The time taken to complete one complete oscillation is called as time period. Okay. So I am writing here the time taken
Sir, and relation between time period and frequency is 1 by f.
yes, we will discuss that also. The time taken to complete one oscillation is called as time period. It's called as beta time period. Okay. Okay, time period of the oscillation. And it is measured in second. It is measured in second. Yeah. Okay. Now we will discuss about fourth concept, and which is the frequency. Okay, so what is frequency? The number of oscillation per second is called as the frequency of sound. Yes. The number of oscillation, oscillation per second is called as frequency. Okay, and frequency is represented by beta nu, like this. Yeah, and like in 1 second it will complete 1 by t oscillation. If we will discuss, we'll go through that example. When we used to say when vibrating object has a time period t, okay, that means it completes one oscillation in sorry, t second. Okay, that means in 1 second it will complete 1 by t. Okay, in 1 second it will complete beta 1 by t. Okay. Okay.
So can we have like a quiz of this chapter?
Okay. Okay. Yes, we will have. Okay. So let me write first the unit of the frequency now.
Sir, it's hertz.
Yes, unit of frequency. Okay, it is
Sir,
hertz.
like, can you explain what's the difference between hertz and decibel?
Okay. Okay. See, this is the hertz and it is represented by beta Hz. Okay, we will discuss that also. Okay, so everyone just take a screenshot first. So the difference between hertz and decibel is, so see, hertz is used to measure the frequency of sound waves. Okay, so I'm writing here hertz is used to measure the frequency of sound waves.
So that's the loudness of sound waves.
Okay, yes, but decibel, okay, decibel is used to measure intensity of the sound. Intensity of sound. Okay, understood?
Yes, sir.
Yeah. So again, just take a screenshot for that, for hertz and decibel. Intensity means how the sound loud is, or maybe it is like
The amplitude of sound.
yes. Okay, so taken the screenshot for that also.
Yes, sir.